All right, this is intended to give you kind of a quick run through of some of the items in Module 17. We have talked about some things in Module 17. We've kind of skipped and hopped around and done various and sundry things, but I want to give you kind of a little bit of a pathway through some of the official Module 17 items. I would recommend that you have your keeper sheets at this point, just kind of handy in case you need to refer to them, because instead of flipping through pages and pages of modules, I may just refer you to something in the keeper sheets. Okay, I will remind you just very quickly that you have two ways of writing, you actually have more than two ways of writing quadratic functions. You can write it in standard form, which is ax squared plus bx plus c, or you can write it in what's called vertex form, which is a times parentheses a minus, or excuse me, x minus h squared plus k, and that is called vertex form because it's really handy-dandy if you need to know the vertex, because the vertex is just that h value, k value. So that's basically the x and y coordinate of the vertex. Remember, the vertex is the point on the parabola where it turns around. Okay, and the axis of symmetry is the vertical line x is equal to whatever h is. Okay, all right, so that's in your notes, but let's get back to page 823 in Module 17. And this is asking you to practice graphing quadratic functions in standard form. All right, so they're asking you to please graph this quadratic function. It is written in standard form, meaning ax squared plus bx plus c, although some of them are negative, that's fine. The first thing you should probably do is find the axis of symmetry and find the vertex. When it is in standard form, this is the vertex. You take the negative b and divide it by 2a. Remember, a is the number in front of the x squared, b is the number in front of the x, and then c is just the number with no variable at all. Okay? Remember, vertex form, you know immediately what the axis of symmetry in the vertex is. Standard form, you have to do a little bit of calculating, but it's not difficult. Okay, so this says to find the axis of symmetry. Just a reminder, our a value, because there is no a value written, we understand that it's 1. Our b value is -4, and our c value is -5. So this says negative b over 2a. b is -4. A is 1. The negative of -4 is just 4, and 4 divided by 2 is 2. So the axis of symmetry is that vertical line x equals 2. Then, to find the vertex is basically the axis of symmetry is your x value, and then put it in the equation to generate the y value that goes with that, and then you'll have the vertex. So I'm going to put in 2 here for x. 2 squared is 4. 4 times 2 is 8. So it's going to be 4 minus 8 minus 5. And last time I checked, that was -9. So the vertex is at 2, -9. Now, they go on and they say, hey, next find the y-intercept, and there's nothing wrong with that. And then it says, hey, find 2 more points on the same side of the axis of symmetry. There's nothing wrong with that, but I'm going to show you a slightly quicker way to have enough points to correctly draw your parabola. Okay, so hang on, let me get to some graph paper. Okay, so we already know that our axis of symmetry is the vertical line x equals 2, which is right there. And we also calculated that the vertex was 2, -9. So this is -2, 4, 6, 8, 2, -9. So that's going to be the vertex down there. Okay, All right. What I recommend that you do is just pick 2 points on either side of the vertex so that you can have enough points to generate a parabola. So for instance, we already know that -2 is where our vertex is. Sorry, not -2, +2. +2, -9 is our vertex. So I'm going to go 1 more, 2 more as far as my x values are concerned. And then I'm going to go the other way. Okay, so that my vertex is kind of the point in the middle. And I'm going to take these and put them in here and figure out what my y values are for these x values. Okay. 3 squared is 9. 9 minus 12 is -3. So 9 minus 12 is -3. Minus 5 more, that's going to be -8. Okay, so 3, -8. All right. Take this one. 1 squared is 1 minus 4 times 1. So 1 minus 4 is -3, and then another -5, and that brings you to -8 also. So 1, -8. All right, put a 0 in here. 0 squared is 0, minus 4 times 0, minus 5, and you get 0, comma, -5. 2, 3, 4, 5. 4 squared is 16, minus 4 times 4, which is 16. So 16 minus 16 is 0, minus 5. You get 4, comma, -5. 4, -5. Okay, and at that point, you should have enough points, probably 5 is your minimum, to sort of see, that's not a perfect drawing, to see the shape of your parabola. And there it is. Okay, I missed that a little bit, but basically, figure out your vertex. Okay, so axis of symmetry is -b over 2a, and then use that to find the y value that goes with that axis of symmetry, and you've got the vertex. And then just do 2 points on either side of the vertex, and you've got enough points to draw your parabola. Okay, now I'm on page 824, and it says a 0 of a function is an x value that makes the value of the function 0. The zeros of a function are the x-intercepts of the graph of the function. A quadratic function may have 1, 2, or no zeros at all. Quadratic equations can be solved by graphing the related function of the equation, and to write the related function, rewrite the quadratic equation so that it equals 0, and then replace the 0 with the y, which is basically what we've been doing. All right, but let me talk about this real quickly. A 0 of a function is any x value that makes y equals 0, okay? That makes the function equal to 0, okay? Then let's talk about this. A quadratic function may have 1, 2, or no zeros. Okay, I'm going to take this sentence right here. A quadratic function may have 1, 2, or no zeros. And I'm going to kind of reuse this graph up here on this page that I didn't actually use the last time. This particular quadratic equation, whatever the equation would be, this has 1 zero or 1 solution because it only hits the x-axis in one spot. Okay. Okay, I'm just going to start sketching. This parabola, although it's messy, also hits the x-axis at exactly 1 point. It has 1 solution. This parabola has 1, two solutions because it hits the x-axis at 2 points. Let's see. This parabola has two solutions because it hits the x-axis at 2 points. This parabola has no solutions because it never hits the x-axis. So there are no solutions to this one. You could have another one down here. No solutions because it never hits or crosses the x-axis. Okay, so just keep that in mind. A quadratic function may have 1, 2, or no zeros. And keep this in mind as well. Zeros are the x-intercepts. Also known as solutions. Okay? So those are kind of all interchangeable.